Okay, so now we're going to look at the 2020 Higher Level Leaving Cert Maths Paper 2, question 2. So we have a circle C. It has equation x squared plus y squared minus 4x plus 2y minus 4 equal to 0. The point A is the center of the circle, so we have the point A here. The line L is a tangent to C at the point T, as shown in the diagram. The point B is 5, 8, and that's on this line L. Find the distance from B to T. Okay, so what you should recognize here is that this here, the distance from A to T is the radius, and that's going to be at right angles to our line L, because a tangent to the circle will meet the radius at the circle at right angles. And also this shape here from A to T to B is a right angle triangle then. So we're going to use that fact. So we can find A because we have the equation of the circle, so we can find the center easily enough. We can also find the radius, the distance here from T to A, by using this equation here. So if we have this distance here, we can find the distance from A to B. We have a formula for that. So we can find the distance from T to B using Pythagoras Theorem. So that's the way I'm going to approach this question. So let's just write down the equation of our circle first. So we have x squared plus y squared minus 4x plus 2y minus 4 equal to 0. Our center we can just read off here. It's going to be half the coefficient of x with the sign changed, half the coefficient of y with the sign changed. So our center is 2 minus 1. Okay, now our radius then is going to be the square root of g squared plus f squared minus c. So we just put those numbers in here now. So our g is, remember our center is minus g minus f. So our center here, our x coordinate is 2, so we're going to put in minus 2 here and square it. And our f here is minus 1, so we're going to put 1 in here. And then we've got minus c here. So minus c, well our c is this number here, so that's going to be 4 plus 4. We've got to change the sign there. So if we do that, we get the square root of 2 2s are 4, plus 1 is 5, and 4 9. So we get the square root of 9, which is just 3. So our radius here is just going to be 3. Now, we've got to find the distance from B to T. So I'm just going to draw this triangle here, this right angle triangle. So we've got a right angle triangle here. We have, let's say, A out here, we've got T here, and B here. So from A to B, so that's from A to B here, we're just going to work that out in a second. We can do that by finding the distance between 2 points, by using the distance between 2 points formula. The distance from A to T we've just worked out as 3, that's the radius of our circle here, so this distance here is 3. And we've got to work out BT. Okay, so I'm just going to work out the distance from A to B next. Okay, so from A to B, so let's do that. So A is the center of our circle, and that's 2 minus 1, so that's A. B is the point that we're given, which is 5, 8. So I'll just call these x1, y1, x2, y2, and the distance then from A to B, that's just going to be the square root of x2 minus x1 to be squared plus y2 minus y1 to be squared. So that will give us 5 minus 2 is 3, 3 3 is 9, 8 and 1 is 9, 9 9's 81, so that gives me the square root of 90 here. Okay, so let me just move this down a little bit. Now, so we have the distance from A to B as the square root of 90. So now we've got to find the distance from B to T. So we have this distance here as 3, this distance here is the square root of 90, and we've got to work out this distance here. So let's use Pythagoras Theorem. So we have the distance from B to T, which we're going to square, plus 3 squared is equal to the square root of 90 all squared. That gives us the distance from B to T squared plus 9 is equal to 90. That gives us the distance from B to T squared is equal to 81, and that finally gives us the distance from B to T as the square root of 81, which is 9. So it's going to be 9, let's say, units. Okay, so that's the first part of this question done. Let's have a look at the second part. We have two circles, C1 and C2. They have their centers on the x-axis. Each circle has a radius of 5 units. The point 1,4 lies on each circle. Find the equation of C1 and C2. Okay, so let's just draw two circles. So we have one circle and we have, another circle. And we know that the point 1,4 lies on each circle. So this is, let's say, the point 1,4 here. Now, we also know that the centers of these circles lie on the x-axis. So if we just draw a line here, let's say that's our x-axis. So we have, say, a center here and we have a center here. We also know that the radius of this circle, the radius of each circle is 5, so we can say that this distance here and this distance here is going to be 5 and 5. Okay, so there's a couple of ways of doing this. There are a few ways actually, but the easiest way is probably just to have a look at the center and the point 1,4. The centers of these circles are going to have coordinates minus g minus f. So the center is going to be minus g minus f. But both of these circles are on the x-axis. This is our x-axis here. So therefore f is just going to be 0. So the centers of these circles are going to be minus g 0. Now we know that the distance from the centers to 1,4 is going to be 5 units. So we can do the distance formula, which is square root of x2 minus x1 to be squared plus y2 minus y1 to be squared. That's going to be the distance, that's the distance between 2 points. In this case, it's going to be our radius. So let's just work through that. So we have the square root of x2, which is, let's say, we'll pick this here as x1, y1. And this here as x2, y2. So we're just going to put these into our equation here. So we have x2, which is minus g minus 1, we're going to square that, plus y2, which is 0 minus 4, which we're going to square, and we know that distance is going to be 5 units. So let's just square both sides. So we have minus g minus 1 to be squared, plus minus 4 to be squared is equal to 25. And we can just multiply this out. So we have g squared, that's going to be plus 2g and then plus 1. And then we have the minus 4 squared, which is plus 16, and that's equal to 25. So that'll give us g squared plus 2g plus 17, and then minus 25. When I bring the 25 over, that's going to give us minus 8. And that's equal to 0. So I just brought this over here, added these two. Okay, so let's just solve this. So we have our factors here. So we have g and g. We have an 8, which is going to be 4 times 2. We want the bigger one to be plus. So that will finally give us a g as minus 4 and plus 2. That will from that then, once we have our two g's, that means we have our two centers. So our two centers are going to be, remember our centers are minus g minus f, and our minus f here is going to be 0. So our centers then are going to be minus g, so that's going to be plus 4, 0, and minus g again, which is minus 2 and 0. So there are two centers of our circles. So once we have our centers, we can just write out our equations. So that means the equations of our circles are, so they're going to be x minus 4 to be squared plus y minus 0 to be squared, which is just going to be y squared, is equal to our radius squared. So our radius is 5, so that's going to be 5 squared, which is 25. And we've also got x minus 2, so that's going to be x plus 2 to be squared, plus, again, it's y minus 0 to be squared, so that's just going to be y squared, and again, it's equal to 25. So that's it. They're the equations of our two circles. Okay, so we can do it another way by looking at our two circles again. So if we have our two circles, and let's say we have our x-axis going through the middle. We know that this point here is 1, 4, and our centers are here and here. We know that our radius is 5. This radius is also 5. And if this point here is 1, 4, that would just mean our y-axis is going to come down, let's say here somewhere. This is our y-axis. So let's say this is our y-axis, this is our x-axis here. We can draw a line down here from that point. This distance up along here must be 4. So we can work out this distance here using Pythagoras Theorem. So we can say 5 squared is equal to 4 squared plus x squared. So that'll give us 25 is equal to 16 plus x squared. That'll give us x squared is equal to 9. That'll give us x is equal to 3. So we know that this distance here in blue, this distance here is going to be 3. You probably spotted that that was a 3, 4, 5 right angle triangle anyway, Pythagorean triple if you like. So if that's 3 out to there, so also from this side we can see that that's going to be 3 as well. If that distance there, if this distance here is 3, that must mean that this point here, because this is our origin here, this point here must be minus 2, 0. Also out here, if this distance here is 3, this point here, because there's an extra 1 here, this must be 4, 0. So that gives us our two centers as well. And once you have the two centers, you can work out the equations as I've done earlier. We have the two centers, we have the radii, so we can easily enough work out the equation of both circles. So that's another way of doing it.